Myself Simna Devi, Assistant Professor, Department of Mechanical Engineering from Lord's Institute of Engineering Technology. I welcome you all for today's session, a brief introduction on heat transfer. Now we are going to study about what is introduction to heat transfer, what are the different laws which are going to govern our heat transfer principle, and also regarding condensation, boiling, and also regarding the applications of heat exchangers. And we are going to throw a light on radiation heat transfer. Now let us begin with the introduction to heat transfer. As we all know that heat transfer is the transfer of heat from one body to another body or from one part of the body to the another part of the body. That means the heat transfer may takes place within the same body or from between the two different bodies, or it may be more than two bodies also. This is regarding the brief introduction to heat transfer. And next thing is regarding what the different modes of heat transfer, how the heat transfer is going to take place in the universe. It is, we all know that matter exists in three different forms. One is solids, liquids and gaseous. So heat transfer is going to take place in solids, liquids and gases. Depending upon this, we have categorized the modes of heat transfer. Here we have been categorized into three different types. One is conduction, convection and radiation. Conduction is such a kind of heat transfer where the heat transfer is going to take place only between the solid bodies, and the convection is the one where the heat transfer is going to take place between the fluids or in the liquids. And the radiation, the name itself indicates normally the type of heat transfer which is going to take place in the solar bodies. And now let us see what are the different laws which is going to govern our heat transfer principle. As we all know that in physics we have been studied about the Newton's laws and different laws which is going to govern our particular subject. In similar way, the heat transfer is such a vast in the universe in which we find that there are different laws which our heat transfer principle is built up. And there are different laws, as I told you. One is law of conservation of energy and thermodynamic laws, that includes all four different laws: zeroth law, first law, second law and third law of thermodynamics. And let us see first one, law of conservation of energy. What is actually energy? Energy is nothing but the capacity to do work. We call it as energy. And the law of conservation of energy states us that the energy cannot be destroyed or it cannot be created, but it can be transferred from one form to another form, and the total energy in the universe remains constant. We have just seen this same concept from our school days. Now what it is actually in true practice? Energy neither be created nor be destroyed. Yes, exactly. Let us talk about the chemical energy which is there in our fuels, such as liquid fuels or the gaseous fuels, or the mechanical energy. We're just going to transfer from one form to another form. Let us take a best example, automobiles. We are going to take our fuel. The fuel may be diesel or the petrol or the gasoline, LPG, CNG. So these are all consists of chemical energy. This is just getting transferred to mechanical energy. That means the energy is neither we are creating nor destroying. We are just going to transfer from one form to the another form of energy, and the total is remaining constant. For example, if you have given some 5 liters of diesel to your automobile and you can just consume some 4 liters, the one remaining is the obviously losses. So this is the exact principle that is applicable in the true practical life regarding law of conservation of energy. And the next thing about the thermodynamic laws. The first thing is zeroth law. First law, second law and third law. The first picture comes into our mind is regarding zeroth law of thermodynamics. Why the name is given as zeroth law of thermodynamics? Why can't we name zeroth law as first law as second law, and second law as third law, and third law as fourth law? The main reason behind this principle is after stating first, second, third laws of thermodynamics, zeroth law was stated, and therefore it was named as zeroth law, because we found that the basics of thermodynamics is hidden in zeroth law, and it was said by Harris Fowler in the year 1935, and it states that when two bodies are in thermal equilibrium with each other, and it is also at the same time it is also in thermal equilibrium with the third body. This is what, and indirectly both the bodies are in thermal equilibrium to each other. This is the basic law, and no other law states about this equilibrium, thermal equilibrium, except the zeroth law of thermodynamics. That is the reason we have named it as zeroth law of thermodynamics. Now let's move to the next law, first law of thermodynamics. First law of thermodynamics is completely based on law of conservation of energy principle, and we already come across what is law of conservation of energy principle. And the first law states us the amount of heat that is supplied for a body is the summation of internal energy and work done. The very simple thing, we consume the food. Let us think 2000 calories of food we are consuming per day, and 1500 calories what are the work done by a human being, and 500 kilocalories is stored as obviously the fat inside a body. The best example can be suitable for the first law of thermodynamics. The summation of internal energy and the work done is nothing but heat supplied. dQ is equal to du plus dW. The cyclic integral indicates that this is a thermodynamic cycle. Now next, let us see about the second law of thermodynamics. Second law of thermodynamics is stated by Kelvin, Planck and Clausius statement. It states that nothing can be derived from low energy region to high energy region without help of external source or energy. In a simple sentence, we all know about the best example of well. How do we get the water from the well? We just tie rope to the bucket, we dip a bucket inside the well and we get the water. This is the practical or the traditional thing of getting the water from the well. The exact thing, we can take it as the best example for second law of thermodynamics. If we just go and stand near the well, we are not going to get the water. So the rope which is tied to the bucket will act as an external source or external medium. Our second law states we cannot derive anything from lower region to higher region without the help of external source. Suppose if you throw a chalk in the classroom, you cannot just get it. Someone has to give us, or we have to bend it and take. That is nothing but some external source. I hope you understood regarding the second law of thermodynamics. Next is regarding third law of thermodynamics. Of course, a thermodynamic laws is a very simple one. If the temperature is zero, the entropy also becomes zero. This is, as we all know that the entropy and enthalpy are the two different parameters that we come across only in heat transfer, or you can say these are the thermodynamic properties, entropy and enthalpy. So these are regarding the different laws which governs our heat transfer principle. Next one, let us move to the, as we have seen water, just heat transfer is how the heat transfer is going to take place in solids, liquids and gaseous. Now let us see what is actually conduction, how it is heat transfer is going to take place in solid bodies. What is convection? How heat transfer is going to take place in fluids or in liquids. And last one is regarding radiation. As we have seen, what is heat transfer? The transmission of energy from one region to the another region, maybe within the same body or from two different bodies. First one is regarding conduction. This conduction was studied by Fourier. He is a French scientist which was studied in the year 1822. And it states that the amount of heat, the same principle is applied even here also. The transfer of heat from one body to the other body or from one part to the another body, but it takes place only within the solid bodies. And here we are going to find out regarding heat flow rate. This heat flow rate can be found by using the formulas Q is equal to minus K dt by dx. And a simple thing, suppose if you want to find out the heat flow rate for a room, if you want to find out the heat flow rate for a building, or you want to find out the heat flow rate for a human body. So these are the different parameters we are going to consider. What is the amount of heat flow rate? That is the relative letter Q, and A stands for cross-sectional area. Of course, this goes on varies from different from geometrical body to the another geometrical body. For a sphere it is different, for a cylinder it is different, for a rectangle it is different, for a square it is different. Cross-sectional area it varies from geometry of the body to the another geometry of the body. And the dt is nothing but the change in the temperature levels, room temperature and the outside temperature. That is what we term it as ambient temperature or outside. The simple thing, other than our body temperature, anything we can consider it as a room temperature or ambient temperature. It's a simple sentence. So this is how we find the heat flow rate in solid bodies. Similarly, we come across even about convection. Convection, the type of heat transfer which is going to take place in liquids or in fluids, and this is of two types. One is natural convection and another is forced convection. Natural convection, we find there is only the buoyancy force, we can term it as it is a driving force. The only driving force in natural convection is buoyancy force. Without even the help of any external source also, the type of heat transfer is going to take place. This is regarding convection. So, and I told you this is of two types. One is natural convection and there is forced convection. Coming to forced convection, we don't find any kind of bouncy force. Then how the heat transfer is going to take place? Because of external source or an external device, we can take such as a blowhole or the motor, something external other than our two bodies. This is regarding the forced convection. So the main difference between the natural convection and forced convection is that in natural convection we find the medium, but we don't see any external source or a device. Whereas in the forced convection we find both medium as well as external source or the device. Here also we are going to find out, we just come across heat flow rate in the liquids or in the fluids by the formula Q is equal to HA delta T. Here Q stands for heat flow rate, it stands for coefficient of convective heat transfer, and A stands for cross sectional area, and delta T or can be termed as DT also, temperature difference or change in the temperature from the body to the surroundings. This is regarding the conduction, convection, and now let us see about the third mode of heat transfer, that is our radiation. The name itself indicates normally the radiation, normally the type of heat transfer that takes place in radiant energy or in the solar bodies or in the waveform, we term it as radiation. And it was stated by Stephen Boltzmann, and he has named a constant sigma 5.67 10 power minus 8 watt per meter square Kelvin power 4. Now we have focused about the different modes of heat transfer. Now let us see about the condensation heat transfer. What is actually a condensation process? Condensation and boiling are two reversible process, we can say. Of course, here also we find that there is a transfer of heat, no doubt. In condensation, it is a conversion from vapor to liquid state, or from the gaseous molecules to slowly it converts into liquid molecules. Whereas in boiling, we find that we just start boiling the water or some liquid, that means which is the liquid form, and it is going to transfer into vapor or to the gaseous state. These are two exact reversible process. And condensation takes place in two different modes. One is film-wise and another is drop-wise condensation process. Now let us look into the what is actually a film-wise condensation process and drop-wise condensation process. This is called as film-wise condensation process, where the transfer of the vapor or the gaseous molecules to the liquid goes by layer-wise. For example, in the winter season, if we park our car at the outside our building, we find this few dense or few fog type. Suppose if you just start rubbing with your hand, you'll find the lines. So that is the best example for your film-wise condensation. Next one is regarding drop-wise condensation. For example, in the if you start heating some water and if you place the bowl and your place covered it with the lid, and you find that there are few droplets in the molecules form, this is the best way of conveying you the practical applications of film-wise and drop-wise condensation. The film-wise and drop-wise condensation both are condensation process where you find that the transfer of vapor or gaseous molecules to the liquid will take place. This is regarding film-wise and drop-wise condensation. Now let us look into the heat exchanger. What is actually a heat exchanger? Where do we find the applications of heat exchanger, or what are the different types of heat exchangers are there? Based on which parameters the heat exchangers are classified. Technically speaking, a heat exchanger is a device that is used for transferring the energy either between the two different fluids or between two different bodies also. This is regarding the heat exchanger. Now coming to the broad classifications of heat exchangers, these are classified according to direct contact, indirect contact, and the main classifications of heat exchangers are parallel flow heat exchanger, counter flow heat exchanger. The names itself indicates what is actually a parallel flow heat exchanger. When both the fluids, that means both liquid, a hot liquid and the cold liquid fluids. Hot fluid and the cold fluid, which transfers, which travels in a parallel direction to each other. This is what we call it as parallel flow heat exchanger. It's a simple thing. We have the two different exchangers, just like a pipes or just like a devices, in which one side the hot fluid is flowing and the other side the cold fluid is flowing. And we all know what is the purpose of heat exchanger, why we have arranged the hot fluid and why we have arranged the cold fluid, just to transfer the heat. And these two are going to travel parallel to each other. That is the reason why it is named as parallel flow heat exchanger. Coming to counter flow heat exchanger, hot fluid and the cold fluid starts traveling in reverse direction. Suppose if the cold fluid starts in one direction and exactly counter upon that, the hot fluid is going to flow. This is regarding the counterflow heat exchanger. Of course, in both in parallel and in counterflow, we are going to find the effectiveness of the and also the efficiency of heat exchangers. And whatever the efficiency or the effectiveness of our parallel flow, counterflow, we are going to use both, especially for the industrial purpose, depending upon our uses. This is regarding the broad classifications of heat exchangers, and mostly we find this use of heat exchangers in power plants where we start producing power or electricity. It may be in steam power plants, it may be in hydel power plant, it may be hydraulic power plant, it may be in thermal power plant. We use the heat exchanger as a main device for conversion of this hot steam. There we in the power plants we find it in the where we go for steam. This is regarding the classifications of heat exchangers, uses of heat exchangers, and also regarding applications of heat exchangers. Now, let us switch on to boiling and condensation again. I'll just explain about what is the condensation process now and boiling. Now, we must and should understand what is boiling versus condensation. Boiling normally, it is a transfer of heat and condensation also transfer of heat. Whereas in boiling, we are going to increase the temperature. Suppose, let us take water at room temperature, hardly 25, 30. And we are going to start boiling the water. How long the liquid water in the liquid form is going to remain the same liquid? Up to a boiling point. Beyond the boiling point, it slowly gets evaporates. Whereas in condensation, it is the reverse way of boiling. Here we are going to reduce the temperature from vapor or gaseous state to liquid. Of course, whatever we have been converted from the molecules from or the water or the vapor state to the liquid state, this is hot liquid, no doubt. But the temperature is less when compared to the primary one. This is the broad classifications, or we can say boiling versus condensation. And boiling normally takes place in the regimes of boiling involves pool boiling, nucleate boiling, and local boiling. Whereas our condensation process purely takes only in two ways. One is film-wise and another is drop-wise condensation process. Now, let us switch on the best example of boiling and also condensation. Now, let us consider water, which is at room temperature, as I told you, maybe 20, 25 or below 30, 35, and we are going to heat it up. So, it is going to evaporate or it is going to vaporize. And the vaporized water again, it is going to form a dense liquid molecules. If you can observe it when you are going to close that same glass with a lid. This is we can find the applications of boiling as well as in condensation. Next one, I explained about how the condensation process is going to take place by demonstrating the small example of parking a car in the winter season. Now, I just want to focus on what are the different types of boiling process. That means how when we start heating the liquid at room temperature, when it is going to convert into the vapor state or to the gaseous state, how it is going to take place. Now, let us look at the first one is free convection. Of course, though it is a boiling, there is we can even call it as a free convection. The main reason behind is the transfer of it is going to take place because of natural convection or because of the buoyancy force. We can see the graph which is starting at the temperature at our room temperature. So if you start increasing the temperature at different temperatures, the water which starts boiling, not only water, even the liquid which starts boiling at room temperature, slowly changing from the liquid state to gaseous state. So at different temperatures, at different stages, we are going to call it as nucleate boiling, pool boiling, and regarding film boiling. After once the film boiling curve is achieved, we don't find any liquid water which is the form of liquid. It is just going to vaporize. This is regarding the broad conversion from water, which is in the form of liquid, to gaseous state. Here, if you want to reverse, that is nothing but our again condensation process. And next one is radiation. So we have seen this in modes of heat transfer. As we all know, radiation is the term of electromagnetic radiation, or we can say it is going to take place in electromagnetic waves. Normally takes place in solar bodies. Of course, nowadays we find electric rice cookers and also thermoflask and also the ovens. Here also we find the applications of radiation or electromagnetic waves. Not exactly the radiation, of course radiation, but it is in the little concern compared to the solar radiation. And the best example, the measured basic light on the earth, electromagnetic waves. And this is the best example of radiation. Here the man is just near the fire camp. If he is going to touch the fire camp directly, then we call it as conduction. That means transfer of heat is going to take place from the fire camp to the man through the radiation, or we can say through waves. And this is how the sun is going to emit it is, and the heat is going to reach the earth in the form of electromagnetic waves. And also we find the applications of radiations in many sectors nowadays, even in the power plants, even in toys, even in the food factories, where the food is manufactured through using artificial intelligence. We find the applications of heat exchangers or the radiations in vast areas in the universe. And next is regarding greenhouse effect. I just want to focus greenhouse effect. If you are not going to control the radiation, definitely there is an increase in the greenhouse gas effect. That is the reason even in the power plants or even in the food beverage industry or in the mechanical industries, we don't prefer much of electromagnetic waves compared to our traditional method of manufacturing the goods, or we can say. And it is hazardous to health, it is also dangerous to the working man, and it is more costly compared to the traditional way of. That is the reason we avoid normally the electromagnetic waves in food production or even in the manufacturing industries. And next one is regarding radiative properties. So what are the different properties which we come across radiation? I've just shown you a simple peak. The sun is going to emit the radiation and earth is going to receive it. How much amount are we going to really receive the same amount which is emitted by the sun? No. Then how? Now let us see, these are the different things: absorptivity, reflectivity and transmissivity. Absorptivity is the one which our earth has capability to receive from the sun, and the reflectivity is one which is again going to reflect back. This is regarding absorptivity, reflectivity and transmittivity, and the same amount it is going to even transmit. And the reflectivity is written by letter rho, and absorptivity is written by letter alpha, transmittivity is written by letter tau. This is the different parameters which are useful for calculating the transmissivity, absorptivity, reflectivity, how much the one body has, as we all know, one is the donor and one is the acceptor, and how much amount of heat is really reflected and how much it is really received. Thanks for watching.